Hello everyone, my name is Akhil. In this video, we are going to discuss about number systems. There are generally so many number of number systems, but we follow something called as decimal number system. What actually is decimal number system? We'll see. So decimal number system. See, this number system is classified into two types. So first one is real numbers and the second number is complex numbers. I think you might have heard about these complex numbers. Complex numbers are those numbers which are in the form of x plus iy. So in that I is imaginary, right? So there are real numbers and there are complex numbers as well. And this I square value is -1. But generally we will not discuss about complex numbers in our sessions. So we will mainly focus upon real numbers. Real numbers is like a mother of all the numbers. You will understand how in 10 minutes. Okay. So real numbers are divided into two types. One is rational numbers and another thing is irrational numbers. There will be rational numbers and irrational numbers as well. The combination of these two, there is one more classification called decimals. We'll see these decimals separately, but we'll mainly focus on rational numbers as of now. What is the definition of rational numbers? Rational numbers are those numbers which are in the form of p by q form. Rational numbers are those numbers which are in the form of p by q form. What are irrational numbers? Irrational numbers are those numbers which are not in the form of p by q form. So what is this p by q form? You can tell any number, right? You can tell example as you can tell the number as 2 by 3. You can tell the p by q form of 1 by 2, or you can tell it as 5 by 4. Can you tell 2 as a rational number? Does it have p by q form? Yes, indeed it has p by q form. See, you can write 2 as 2 by 1 as well. So this we call it as an integer. We'll see what is an integer as well. But what are irrational numbers? Why you can't write? What are those numbers which you can't write in the form of p by q form? So I'll give you an example. What is root 2 value? Root 2 value is nothing but 1.414 so on. You don't know how many digits are there in the numerator and you don't know how many zeros we have to take in the denominator. That's why you can't write this root 2 in the form of p by q form. That is why we are calling root 2 as irrational number. So if you want one more example, root 3 value is 1.732. If you take any number under prime, any prime number under root, always these numbers we call it as irrational numbers. We call it as surds as well. That is a different chapter, that also we will see coming along. But any number which you can't write in the form of p by q form, you call this one as irrational number. So that is a basic difference between a rational number and an irrational number. So rational numbers are also divided into, let's say, two types. Basically there are two types. First one is integers and the next one is fractions. You can take only two types of numbers. Just give me 1 minute. Okay, so integers. What are integers? Any number. If you take a number line, as we have discussed previously, if you take any number line, what will be the middle value? Middle value will be 0. What will be the right side of 0? These we call it as positive numbers and these we call it as negative numbers. So this will be also until infinite. So integers are a combination of three types of numbers. One is positive numbers, one is negative numbers, and there is one thing called as 0 as well. It acts like a bridge between positive numbers and negative numbers. So there will be no chance of decimals here. So let's move forward. What are the types of fractions? There are basically three types of fractions. First fraction is, we call it as proper fraction. And the second one is improper fraction. And the third one is mixed fraction. So what is this proper fraction? Proper fraction means, I told you this is a subset of rational number, right? That means the fractions are also should be in the form of p by q form. So P by Q form, I have told you P by Q form, right? Whenever P is less than Q, whenever is numerator is less than denominator, we call these numbers as proper fractions. And a denominator, if you take it as 3, and numerator if you take it as 2, then 2 by 3 is also a proper fraction, right? Give me some more examples. If you take this one as 4, this one as 5, this is also a proper fraction. But what are improper fractions? Whenever your denominator is less than, or your numerator is greater than denominator, just a completely opposite to proper fractions, we call it as improper fractions. So examples will be 5 by 4, so you can take 11 by 9, or you can take 8 by 5. Anything you can take. You can, whenever the numerator is greater than denominator, we generally call that one as improper fraction. The last one is mixed fraction. Mixed fraction you can convert it to improper fraction as well. I think you might have heard as well. If you take 1 2 by 3, how can you convert this one into an improper fraction? Just you have to multiply these two numbers. What is 1 into 3? It is 3. And what is 3 plus 2? That is 5 by 3. If you take generally, if you take this one as A, B by C, just you have to multiply these two and you have to add the product to B. So AC plus B by C. So this is how you can convert this mixed fraction into an improper fraction. So this is the basic classification. We will see what are even numbers, what are odd numbers, what are whole numbers, what is natural numbers and all. But you have to understand this is the basic classification of number system. We call our number system as decimal number system. Those are classified into two types. One is real numbers and there is complex numbers. Generally we will not discuss about complex numbers in our sessions. That's why we are focusing only on real numbers. Real numbers are two types, rational numbers and irrational numbers. Generally rational numbers are those numbers which are in the form of P by Q form. Irrational numbers are those numbers which are not in the form of P by Q form. The examples are root 2 and root 3. The rational numbers are further divided into two types. One is integers, another one is fractions. Integers are those numbers combination of three types. One is 0, positive numbers and negative numbers. Fractions are also three types. Proper fraction, improper fraction and mixed fraction. I have given the examples as well. So moving on, we will see what are the we have seen the integers, right? Let's start again with integers. There are further classification as well. Suppose this is an integer line. Middle what will be there? Middle 0 will be there. What will be the right side of 0? So it will be 1, 2, 3. All these one we call it as positive numbers, right? So next, minus 1, minus 2, minus 3, so on. These are negative numbers. If you take only positive numbers, those numbers are called as natural numbers. What are natural numbers? Natural numbers are starting with 1 to infinite. Only the positive numbers we take it as natural numbers. While whole numbers, if you include 0 as well, then we call it as whole numbers. Okay, so this is 0, 1, 2, 3, so on, infinite. So these we call it as generally negative numbers only. Okay, so what are odd numbers, what are even numbers? Natural numbers are divided into two types. One is even numbers and one is odd numbers. Generally even numbers are those numbers which are divisible by 2. Odd numbers are those numbers which are not divisible by 2. So if you take every other alternative number, if you take 2, 4, 6, 8, so on to infinite, we call these numbers as even numbers. If you take the other numbers 1, 3, 5, 7, 9, those numbers are called as odd numbers. This is a simple classification, right? Natural numbers are divided into two types, even numbers and odd numbers. Whole numbers, extra 1 0 will be there. That's it. But we will further classify this natural numbers. Natural numbers again there is one more classification. Natural numbers are divided into three types. Again, What are those three types? One is prime numbers, another thing is composite numbers. Can you guess what is the other? I have told you there are three types, right? First one is prime numbers, another one is composite numbers, and the third type is none other than 1. Why we are calling 1 as neither prime nor composite? What is the definition? In order to get that, why we are calling that, we have to know what is the definition of prime numbers. Most of the people will tell the numbers which are divisible by 1 and itself is called prime numbers. That is not the actual definition of prime numbers. The actual definition of prime numbers is the numbers which are having exactly 2 factors. The numbers which are having exactly 2 factors are called as prime numbers. If I take any examples, if I take the first prime number is 2, that is the only even prime number. 2, 3, 5, 7, 9. So 9 will not come. 9 has the factors, right? 9 has more factors. 11, 13, 17, 19, so on. So what are the factors for 2? Factors, what is the meaning of factor? Factors are those numbers which can divide the given number. Can 1 divide 2? Yes. 2 times it can divide 2. Can 2 divide 2? Yes, it can divide 1 time. So factors are those numbers which can divide the given number, right? I am telling that prime numbers are those numbers which have only exactly 2 factors. So 1 is 1 factor, 2 is 1 factor. 1 is actually common for all the numbers. So another number, if I take a 1, 3, these are the factors. 5, it is 1, 5. Yeah, I think you might be correct, but it is not exactly the correct definition. It is not 1 and itself, because if you take 1, what are the factors of 1? 1 is divisible by 1 and 1 is divisible by itself also. But we are not taking this one as a prime number because 1 is only having 1 factor. 1 is only having 1 factor. That is the reason why we are not calling this one as prime numbers. Now moving on, what are composite numbers? Composite numbers are those numbers which have more than 2 factors. More than 2 factors. So what are those numbers? What is the first composite number means? First composite number is 4, and then you can take it as 6, and then it is 8, and then it is 9. We'll see, there are so many numbers. What are the factors for 4? Which are the numbers which can divide exactly 4? Obviously 1 will divide 4, 2 will divide 4, 3 will not come in 4 table, right? 3 table 4 will not come, or 4 will come in 4 table as well. If you take 6, 1, 2, 3, 6. If you take 8, it is 1, 2, 4. 1 table and 2 table, and in 4 table 8 will come. None other table consists of 8 as a number. So, or you can tell 1 can divide 8, 2 can divide 8, and 4 can divide 8 as well. So these are the three types of numbers in natural numbers. One is prime numbers, one is 1, and another thing is composite number. I hope I am clear. So if you have, I think you will not get any doubts here. Like barring this one, the definition, it is not 1 in itself, it is exactly 2 factors. I hope I am clear. Now moving on, we have not seen decimal part, right? Let's focus that one. Now what are decimals? Now I'll write 3 kinds of numbers here. First thing, I'll take 0.3 or 0.54, 1.67, 8.35, 4. Let's take like this. Now what is the difference between these numbers and this number? If I take 0.6666, so on, 0.585858, so on, or 1.636363, so on. I'm going to write another type of decimals. Now 8.41467, so on. What is pi value? Pi value is 3.142856, so on, right? Now 7.6725, so on. What is the basic difference between these three numbers? We'll see. Now if you observe here, you can write 0.3 as, you can write this one as 3 by 10 or not. You can write this one as 54 by 100. You can write this one as 167 by 100. And you can write this one as 8354 divided by, how many zeros are there? That depends upon the decimal, right? After the decimal, how many digits are there? 3 zeros we have to take. Now if you see these two, what is the basic difference between these two? What is the basic difference between these two? If you can see, the decimal is being stopped here. Yes or no? The decimal is being stopped here, but the numbers are going after the decimal as well. Okay. In English language, we have a word called termination. Have you heard about that? Termination basically means it is stoppage. The decimals are stopping here or not? Yes, the decimals are being stopped here. So that's why we call it as terminating decimals. What are these decimals called as? If the decimal is being stopped after some time, you call those numbers as terminating decimals. But here the decimals are stopping, yes or no? No. If the decimals are not being stopped, we call those decimals as non-terminating decimals. What are the decimals? Non-terminating decimals. Next, now what is the basic difference between these 2 and 3? If you see, the decimal is being stopped here, yes or no? No, the decimal is not stopping here. So we call these decimals as non-terminating decimals only. Non-terminating decimals. But these are also non-terminating decimals, these are also non-terminating decimals. But what is the difference between second and third? Why I have written second and third specially? Because if you see, in second and third, these numbers are the same numbers which are being repeated. Yes or no? Here 6 is the only number which is being repeated. Here the numbers are 5 and 8, none other than 5 and 8 are repeating there. But here if you take 6 and 3 are only repeating after the decimal. So there is one more word called recurring. What is the meaning of recurring? Recurring means repetition. So what is the meaning of recurring? Recurring is nothing but a repetition. Here the decimals after the numbers after the decimal are being repeated. So we call these numbers as recurring decimals. But are the decimals being stopped here? No. But are the decimals being repeated here? No. So these decimals are called as non-terminating and non-recurring decimals. Okay. So these are basically 3 types of decimals. First one is terminating decimal, second one is non-terminating and recurring decimals, and the third one is non-terminating and non-recurring decimals. The terminology of these 3 are very, very important. Okay. So suppose they will ask you one question. If they are asking one type of question like this, we'll see what are these type of questions. But they will not give you what is the answer directly in the solution or in the options. They will tell you which type of decimals are these, whether these are recurring decimals or non-recurring decimals. If you want to choose one of the options, you have to know what are the types of decimals, right? You have to know what is the meaning of termination, and you have to know what is the meaning of recurring as well. That is the reason why I have told you. So this is the 3 types of decimals: terminating, non-terminating, non-terminating, and here it is recurring, and here it is non-recurring. So moving on. So this is a basic classification of number system. We follow decimal number system, right? Now we are going to discuss one more topic which is very, very important when it comes to shortcut. If you want to learn like mensuration, whenever mensuration is very, very calculative, right? When it comes to 2D or 3D, if you want to answer the question very faster, you have to know what is the divisibility rules. We'll see what is the meaning of divisibility rules first of all. Okay. Divisibility rules. Now we'll see generally 1 to 19 divisibility rule. First of all, what is the meaning of divisible? If I tell you 8 is divisible by 2, what is the meaning of 8 is divisible by 2? So whenever you are dividing 2 with 8, so what will be there? 2 4s is 8, right? You are getting what is the remainder? You are getting the remainder as 0. Whenever you are getting remainder as 0, this is very important. Whenever you are getting remainder as 0, then you can definitely tell that number, that particular dividend is divisible by this divisor. We'll see what is remainder theorem and all, what is the dividend divisor and all. But if you take this number, definitely will be divided by or divisible by this number, when you can tell that? Whenever the remainder is 0. But don't you think this is very lengthy method to check? If I have only one number, if I take 512 divided by 2, then it will take some time, right? How can you tell whether a number is divisible by 2 or not? How can you tell in 1 or 2 seconds? That we are going to see now. So just give me 1 second. Okay. Now how can you tell whether a number is divisible by 2 or not? Directly. How can you tell whether a number is divisible by 2 or not? If you check the last digit, if the last digit of that number is either 0, 2, 4, 6, 8, one of these 5 numbers, then you can definitely tell that particular number is divisible by 2. If I take the example 5, 6, 7, 8, if you want to check, there is one method, right? In school level we used to do this one. If the remainder is 0, then you can tell the number is divisible by 2. But what is the direct shortcut here? If you check the last number, so if you see the last number, what is the number here? It is nothing but 8, right? I have told you, I have given you 5 numbers. If one of the numbers falls as the last digit of the number, then definitely this number is divisible by 2. If you take another example, 1, 2, 3, 4, 5, 6, tell me, is this number divisible by 2? Yes, indeed. What is the last number? It is 6. So 6 is nothing but an even number, right? So these are all even numbers barring 0. So if it is 0 or an even number, then definitely the number is divisible by 2. Now how can you tell whether a number is divisible by 3 or not? Divisibility rule of 3 says if sum of digits is divisible by 3, then the entire number is divisible by 3. If you see, sum of digits should be divisible by 3. Now if I take example 6318, is this number divisible by 3 or not? What you have to just do means, you just add all the numbers, 6 plus 3 plus 1 plus 8. What is 6 plus 3? 9. 9 plus 1? 10. 10 plus 8? It is 18. If 18 comes in 3 table, then this entire number is divisible by 3. Or you can check. 3, 6, 1, 8, it is 2 times, it is 6. It is 3, 1 times, it is. Now if you take 18, what you will do? You will take 1 0 right here. So this is 6 times, this is 18. If you want to tell, but this is a very lengthy method of calculating. What I am telling the shortcut, if you just tell sum of all digits is divisible by 3, then the entire number is divisible by 3. If I take all the sum of all digits, it is 6318, I am getting 18. 18 will come in 3 table or not? Yes, indeed it does. So that's why this 6318, 6318 is divisible by 3. So moving on, how can you tell whether a number is divisible by 4? This is very important. Entire unit digit concept will depend on this divisibility rule only. So the shortcuts are very important. How can you tell whether a number is divisible by 4 without actually dividing it? So you have to just check the last 2 digits of a number is divisible by 4. Then entire number is divisible by 4. If you take the example 2304, so this 04 will come in 4 table or not? Yes. Next 5684, 84 will come in 4 table? Yes, it is 21 times, right? So if you check the last 2 digits of a number, if it falls in the 4 table or if it is divisible by 4, then this entire number is divisible by 4. So what does the divisibility rule of 2 says? It is either one of 0, 2, 4, 6, 8 should fall as last digit of the number, then the entire number is divisible by 2. What is divisibility rule of 3 says? If the sum of digits is divisible by 3, then the entire number is divisible by 3. Now how can you tell whether a number is divisible by 4 or not? If you check the last 2 digits of that number, if that number is divisible by 4, if that last 2 digits of the number is divisible by 4, then the entire number is divisible by 4. This is 4 is very important. So moving on. Now how can you tell whether a number is divisible by 5 or not? So this is very simple. Last digit should be 0 or 5. If the last digit of that number is either 0 or 5, then you can tell that entire number is divisible by 5. If you take one example, it is 2305. Yes, what is the last number? It is 5. If you take one more example, 2400, what is the last number? It is 0. If the last number is either 0 or 5, then the entire number is divisible by 5. How can you tell whether a number is divisible by 6 or not? So 6, what are the prime factors or what are the factors which are having HCF as 1? So 2 and 3. 2 and 3. You have to check. If you are telling that a particular number is divisible by 6, then that particular number should be divisible by 2 and 3. So the number should be divisible by both 2 and 3. So if you take an example, if you want to check whether a number is divisible by 4 or not, 6 or not, you have to just check whether that number is divisible by 2 and 3 or not. So if you take one number, if you take 2304, how can you tell whether a number is divisible by 2 or not? You just have to see the last number, right? What is the last number here? The last number is nothing but 4. So it is divisible by 2. How can you tell whether a number is divisible by 3 or not? So the sum of digits is divisible by 3, right? So what is the sum of digits? It is 2 plus 3 plus 0 plus 4. It is 5 plus 4, it is 9. So 9 comes in 3 tables. So it is divisible by 6. Then the entire number is divisible by 6. So here it comes in 3 table, right? It is divisible by 3 and the entire number you can tell it as divisible by 6. Now if you take any other example, if you take 2, 6, 4, 2. Let's check. I am taking any one random number. You have to just check whether this number is divisible by 2 and 3 or not. So what is the divisibility rule of 2 says? The last number should be 2, right? Or 2, 0, 6, 4, 8. Yes, this is correct. How can you tell whether a number is divisible by 3 or not? So the sum of digits should be divisible by 3. 2 plus 6 plus 4 plus 2. What is 2 plus 6? 8. 8 plus 4, 12. 12 plus 2, it is 14. 14 will not come in 3 table. So it is not divisible by 3. If it is not divisible by 3, it should not be divisible by 6 as well. So this number is not coming in 6 table. Okay, it should be both 2 and 3 like this. If you have two ticks like this, if you have 2 correct, then this is also correct. Unless and until it is not divisible by 2 and 3, then it is not divisible by 6. It should be divisible by both 2 and 3 to be qualified as divisible by 6. So one more. Now how can you tell whether a number is divisible by 7 or not? So let me take one example first. This is not particular that you have to learn 7, but I am telling you because 7 is very important. I told you 4 is very important, right? Like that 7 is very important when it comes to mensuration topic. I'll tell you why it is important when we are discussing about mensuration. Now just I will follow 2 steps to check whether the number is divisible by 2 or not. Let me take one example. If I take one example as 1428, suppose. Okay, just multiply the last digit into 2. What is the multiplication of last digit into 2? 8 into 2 is 16, right? Now what is now 142 minus 16? There is one proper way, but I'll do like you. It is 12, this is 6 and this is 3 gone and this is 1 and this is 1, right? Again, how can you tell? Take last digit into 2. Again minus 12. How much is the remainder? If it is 0. If it is 0 or if it is coming in 7 table, then this entire number is divisible by 7. Now if you want, if you take 217, suppose this is divisible by 7 or not, what you will do? You just take the last number, you multiply with 2. How much it is? 7 2s are, it is 14 minus 14. Now how much you are getting? 21 minus 14, it is 7. If it is 2 digit or 3 digit, you can apply the same for this number, but it is not needed here because we got only 7 here. 7 will come in 7 table or not? Yes. Then you can tell that the 217 is perfectly divisible by 7. Now what is the 2 steps? Unit digit you multiply with 2. The same process will be there for many other numbers coming on. Just take the resultant number minus remaining numbers. You have to just take the difference. You don't forget. You forget about minus or plus. What is that number? You just have to take the difference between the resultant number and the remaining numbers. What is the meaning of resultant number? Means whenever you are multiplying 8 into 2, what number you are getting? 16, right? That resultant number you have to minus from the remaining numbers of 142. The same here. Whenever you are multiplying 7 into 2, what you are getting? 14. So that's why I am calling this one as a resultant number, and this 21 I am calling it as remaining numbers. So if you take the difference between the remaining numbers and the resultant number, whatever the number you are getting, if that is 0 or if it is coming in 7 table, then that number is divisible by 7. Clear or not? Once again we are going through, we will go through this one. 5, 6, 7, the last digit is either 0 or 5, then you can definitely tell that will come in 5 table, right? It is divisible by 5. Now how can you tell whether a number is divisible by 6 or not? Just the last 2 digits of the number should be divisible by 6. Now how can you tell whether a number is divisible by 7 or not? Just you have to check the last digit, unit digit you multiply with 2, and the resultant number you have to subtract from, or you have to take the difference between resultant number and the remaining number. If that number comes in 7 table, then that entire number is divisible by 7. So moving on. How can you tell whether a number is divisible by 8 or not? Just you have to see the last 3 digits. The last 3 digits of that number is divisible by 8, then that entire number is divisible by 8. Okay, if you take one example, now 23408, 408 will come in 8 table. Yes, it will come. If you take 49512, so 512 will come in 8 table. Yes, 512 is nothing but 8 into 64, right? This is nothing but 8 cube. So 512 will come in 8 table. So if you check the last 3 digits, it is more than enough. Now moving on. Now how can you tell whether a number is divisible by 9 or not? Now the sum of digits should be divisible by 9. If you take one example, if you take the example as 635427. Now what is 6 plus 3? 9. 5 plus 4? 9. It is 2 plus 7? It is 9. So it is 9 plus 9 plus 9, which is 27. 27 will come in 9 table or not? Yes. 9 either is 27, right? Then this entire number is divisible by 9. How can you tell? Just you have to do the sum of digits, and if you are getting the sum of digits as a multiple of 9, then that entire number is divisible by 9. Now how can you tell whether a number is divisible by 10 or not? 10 is very easy. 5 is last digit is 0 or 5, right? So if for 10 it is only last digit should be 0. Last digit should be 0. There is no other number should come here other than 0. If you get any other number, if you take 2300, the last digit is 0. That's why it will come in 10 table. If you take the number as 2465, it will not come in 10 table because the last number is 5, right? It should be 0. If it is 0 only, if it is like 2460 only, you can tell the answer is divisible by 10. Okay, so in that 9 is very important. I have told you 4 is important, and what I have told you, 7 is very important when it comes to mensuration, and 9 is also very important. Now moving on, let's see how can you tell whether a number is divisible by 11. 11 is very important when it comes to mensuration. 7 and 11, you will understand the use once you see mensuration topic. Without actually solving the question, by using this divisibility rule, you can eliminate at least 2 options. Sometimes you can eliminate 3 options, you will be left with only 1 option, right? Directly you can put that answer. When it comes to sphere or cone, there is something called as pi in the formula. So whenever you are using pi means what? Pi means nothing but 22 by 7. In 22 you can see one number, it is nothing but 11. You can apply 11 divisibility rule and 7 divisibility rule to check the options whether those numbers are going with 11 and 7 or not. Okay. Now how can you tell whether a number is divisible by 11? It is nothing but sum of odd places minus sum of even places should be 0 or 11. Now what is the meaning of sum of odd places minus sum of even places is 0 or 11? Now if you take 2, 4, 6, 8, how much you are getting? 2, 4, 6, 8. Suppose this is 6 again. Just give me 1 minute. Suppose this is 4. Suppose this is a number. Now what is the odd places and even places? Odd place is this one, even place is this one, odd place is this one, this is even place, this is odd place, right? So I am writing odd places at once. Odd places. So if you take, what are the odd places? 2, 6, 4, right? 2 plus 6 plus 4, I am telling sum, right? So just add all the odd places, you will get how much? This is nothing but 12. Next, even places. What are the remaining numbers? You just add alternatively. What are the even places? Even places are just 4 and 8 only. That is nothing but 12. Now what is the difference between 12 and 12? It is 0. If it is 0 or 11, then this entire number will come in 11 table. Let me take one more example. I think you will understand more now. If I take the number as 14641, you can directly take this one as 11 power 4. You will understand when you hear about compound interest or mensuration. This is very important number. But let's focus only on 11 divisibility rule as of now. Just take the odd multiples, odd places. 1 plus 6 plus 1, it is 8. What is 4 plus 4? It is 8. 8 minus 8, it is 0. Clear or not? Now I told you it can be 0 or 11, right? We will take one multiple. Now if you take 464, 462, it is 6 and 6 minus 6 is 0, right? If you take 594 also will be same. 5 how much is this? 559 if I take. What is 9 plus 5? Sorry. 47 into 11. If you take is 7, this is 3 and this is 5, right? Okay. What is the addition of these two? These two addition is 12 and this 2 addition is, if you take 517, if I take 517, so 12 minus 1 is 11, right? So now we are getting. So if you take one more number, 924. What is 9 plus 4? 9 plus 4 is 13. 13 minus 2 will get 11. So odd places is 9 and 4. Even places is only 2. We have only one digit there. So generally you can check alternatively. You will get more the times as 0, less number of times as 11. But you have to focus on both 11 and 0. This will be very useful when it comes to mensuration topic. Let's discuss that, why it is useful in mensuration when it comes to these type of formulae in mensuration. Pi r square, 4 pi r square, why we are taking directly, you will know the use of it. Just try to remember, try to take a picture of this one in your mind. Whenever you can make use of 11, you have to use it. Whenever you want to, because this is mainly for shortcuts, right? This divisibility rules is mainly based upon shortcuts only. So moving on. So from here it will be very easy. If you forget from 12 to 19 is also, it is no problem, but 1 to 11 definitely you have to know all the divisibility rules. For more knowledge I am giving you just 12 and 13, 14, 15, 16, 17, 18 and 19. How can you tell whether a number is divisible by 12 or not? You have to just check the numbers should be divisible by both 3 and 4. If the numbers are divisible by both 3 and 4, only you can tell the number should be divisible by 12. How can you tell whether a number is divisible by 13? So it is same as 7. Just recall 7. What we are doing in 7? You have to just multiply the unit digit with 2 and you have to subtract the remaining numbers minus the resultant number, right? It is same as something like this. So what is unit digit? You have to multiply with 9. Same process, 2-step process only. Unit digit you have to multiply with 9 and you have to do resultant number, difference between resultant number and remaining numbers. Now if you take the numbers of 1, 3, 2, 6. Now what you will do? 6 9s are, it is 54. You have to take the difference, right? So it will be 78. 78 will come in 13 table. Yes, 13 6er. 13 6er is 78. So you can tell this number is directly going with 13 table. Our 1, 3, 2, 6 is divisible by 13. Divisible meaning remainder should be 0. Don't forget that again. Okay, remainder should be 0. How can you tell whether a number is divisible by 14 or not? How can you tell whether a number is divisible by 14? Number should be divisible by both 2 and 7. These are co-prime numbers, right? What is the meaning of co-prime numbers? Also we'll see. Co-prime numbers are those numbers which are having highest common factor or the common factor as 1 only. What is the factors of 2? It is 1 and 2. What are the factors of 7? It is also 1 and 7. It is 1 and 2. What is the only common factor? It is 1, right? So the highest common factor also will be 1. So just divide 2. 14 can be written as 1 into 14 and 2 into 7. So you just take these numbers. Here also you can write 12 as so many numbers, right? 1 into 12, 2 into 6, 3 into 4. Why I am taking only this number? So anyway, you have to forget this one. We have to check for 12, right? You have to take further numbers, not 12. So 2 and 6. What are the common factors for 2 and 6? Common factor is 2, right? For 2 and 6. But common factors for 2 and 7 is only 1. If the highest common factor for these two numbers is 1, then only you have to take those kind of numbers. Those should be co-prime numbers. So here, what are the co-prime numbers? This is 2 and 7. Same like 12. 12 says 3 and 4. 13 says unit digit should be multiplied with number. Sorry, unit digit should be multiplied with 9. And the second step is a resultant minus remaining numbers. And the 14 says number should be divisible by both 2 and 7. Clear? Let's move on. Let's move further. 15. How can you tell whether a number is divisible by 15 or not? Just you have to, number should be divisible by both 3 and 5. 3 and 5 are also co-prime numbers only, if you see. So how can you tell whether a number is divisible by 16 or not? Numbers are divisible by, how can you tell whether a number is divisible by 16? How can you tell whether a number is divisible by 8? You will check last 3 digits, right? Now how can you tell whether a number is divisible by 16? Last 4 digits should be divisible by 16. Okay, last 4 digits we'll see in order to check whether the number is divisible by 16 or not. So how can you tell whether a number is divisible by 17 or not? So it is same as 13. Last digit you have to multiply with 5. That is the first step. The second step is a resultant number minus remaining numbers. Now if you see 153. Now what I have told you, last number should be multiplied with 5. But 3 5s are 15, you are getting it as 0, right? So let's take one more number, 1 7 3 4. You take the last number multiplied with 5. Now what is 4 5s are? 20 if you take, minus if you take. So this is 153. 153 will come in 17 table, yes, here only we have seen. 17 9s is 153, right? So you can tell that this entire number is divisible by 17. How can you tell? Because you are getting this number in 17 table. If you want to go further, you can take 3 5s, it is 15. If it is getting 0 or a multiple of 17 in this remainder, then the entire number is divisible by 17. Now let's see only 18 and 19. Number should be divisible by both 2 and 9. So let's write 18 in some forms. 1 into 18, I told you 18 you have to not take. Anyway, we have to take further numbers, right? So you can write this one as 2 into 9. You can write this as 3 into 6. Any other 4 table, 5 table, 6 table, 6 table, anyway we have got here. Now why we are eliminating this one? So what are the factors for 3? 1 and 3. What are the factors for 6? 1, 2, 3, 6. What is the highest common factor? Highest common factor is 3. I told you the number should be co-prime numbers, right? So these numbers are co-prime numbers. So that's why it should be 18 should be taken as 2 and 9. You have to check the divisibility rule of 2 and you have to check the divisibility rule of 9. So divisibility rule of 2 states the last number should be divisible by 2 and divisibility rule of 9 says the sum of digits should be divisible by 9. So 19 we'll see here. 19 is also same as 7, 13, 17. So here the only change, what is the divisibility rule of 7 says? Last digit we will multiply with 2 and we will take resultant number minus resultant number or resultant remaining number minus resultant number. One is the same, these both are one and the same. If you take reverse also, it is no problem. How can you tell whether a number is divisible by 19 or not? It is same as 7. A last digit should be multiplied with 2, but the second step is a bit different from remaining numbers plus a resultant number. Plus you have to take here. Only difference is plus you have to take here, you have to take minus. So if you take one number 1 3 1 9 3 8, if you take into 2, if you take, it will be how much? This is 16, but you have to add. You have to add, right? It is 9 and this is 0 and this is 2. Now if you multiply this one again with 2, somewhere we have done wrong. 1938 into 2, it is 18. If you add 38, so 20 plus 18, it is 38, right? So 38 will come in 9 table or not? Yes. If you take one number, if you take 171, if you multiply with 2, I am taking a simpler example. 1 into 2 is how much? 2. Just you have to add these two numbers, right? What is 17 plus 2? It is 19. 19 will come in 19 table. So that's why this 171 and this 1938 both are divisible by 19. So this is it. This is from 1 to 20 divisibility rules, right? So let's see from the top again. Let's revise and let's conclude the session here itself. So let's come from the start. What we have seen until now. First we have started with classification, right? So we are going to follow decimal number system. Decimal number system is divided into two types, real numbers and complex numbers. Complex numbers are those numbers which are having the form x plus iy. In that I square is -1, but we are not going to discuss complex numbers in our sessions. We'll mainly focus on real numbers only. Real numbers are divided into two types, as you can see here, rational numbers and irrational numbers. Rational numbers are those numbers which are in the form of p by q form, and irrational numbers are those numbers which are not in the form of p by q form. Generally those are, we call it as surds, under root prime. Or if you take root 2 value, you can't, it is near to impossible to write in the form of p by q form, right? Then what are rational numbers? Rational numbers are those numbers which are you can write in p by q form. What are the examples? 2 by 3, 1 by 2, 5 by 4 and all. Now rational numbers are further divided into two types, integers and fractions. Integers are those numbers, it is a combination of three types. One is 0, positive numbers and negative numbers, and fractions are of three types as well: proper fractions, improper fractions and mixed fractions. So moving on, we have seen something called as natural numbers, whole numbers. Natural numbers are those numbers which are only positive in nature, but whole numbers you have to take 0 as well. So natural numbers are further divided into prime numbers, 1 and composite numbers, right? What are prime numbers? Just recall. Prime numbers are those numbers which are having two factors. One has only one factor, and composite numbers are those numbers which have more than two factors. You can see the examples here. The first prime number is 2 because those are having only two factors, but the first composite number is 4 because it has three factors. Now what we have seen, decimals, there are three types of decimals. First one is terminating decimal, and the second one is non-terminating and recurring decimals, and the third type is non-terminating and non-recurring decimals. What is the meaning of termination? Termination means stop. Suppose the decimal is being stopped after some time anywhere in the number, then we call it as terminating decimals. If it is not going to stop like this, we call that numbers as non-terminating decimals. There is something called as recurring numbers as well. Recurring is nothing but repetition. If you see the pattern for 2 and 3, these numbers are repeating, same number of type of numbers are repeating, but here the different numbers are coming after the decimal. So if it is not repeating, you have to tell it as non-recurring. If it is repeating, you have to tell it as recurring decimals. These are the three types of decimals. You have to know these three types of decimals in order to eliminate the options. Now we have seen something called as a divisibility rules. What is meaning of divisible? Whenever you are dividing any number with another number, if the remainder is 0, then you can tell the entire number is divisible by that particular number which you are taking in the form of divisor. You can see here, whenever you are dividing 2 with 5, 6, 7, 8, then the remainder obtained will be always 0. Now how can you tell? These are shortcuts I have told you, right? It is near to impossible answer this question using this method in the school level. It will take a lot of time, but if you are going with divisibility rules, you can tell the answer in 1 second itself. Now how can you tell? The last number should be divisible by 2, or the last number should be 0, 2, 4, 6, 8. How can you tell whether a number is divisible by 3? Sum of digits should be divisible by 3. And how can you tell whether a number is divisible by 4? Last two digits should be divisible by 4. How can you tell whether a number is divisible by 5? The last digit should be 0 or 5. How can you tell whether a number is divisible by 6 or not? The number should be divisible by both 2 and 3. How can you tell whether a number is divisible by 7? The last digit, when you multiply with 2, it yields another number. We call it as resultant number. You just subtract the resultant number from the remaining numbers. If that number is 0 or if it is a 7 multiple, both times you will get that number is divisible by 7. So here 1428 and 217 both are divisible by 7. Now how can you tell whether a number is divisible by 8? The last three numbers of a number last three digits of a number, if it is divisible by 8, then the entire number is divisible by 8. How can you tell whether a number is divisible by 9? This is very important. The sum of digits should be divisible by 9. How can you tell whether a number is divisible by 10 or not? The last number should be 0. Always it should be 0. Last number should be always 0. How can you tell whether a number is divisible by 11 or not? The sum of odd places minus sum of even places, if that difference should be 0 or 11, definitely the answer should be divisible by 11. If you take one example, it is 2, 4, 6, 8, 4. If you take the odd places, if you take every alternative numbers, if it is 2 plus 6 plus 4, it is 12, and here 4 plus 8 is also 12. So 12 minus 12, it is 0. If it is either 0 or 11, then the numbers is divisible by 11. So if you take one more example, I have told you 517, it is 12, and 12 minus 1 is 11, and here 924, 9 plus 4 is 13, 13 minus 2 is 11. So these kind of numbers will always fall in 11 divisibility rule. So moving on, until here it is very important. So 12, it is 3 and 4, 13 is last number into 9, and resultant minus remaining numbers. How can you tell whether a number is divisible by 14 or not? Number should be divisible by both 2 and 7. How can you tell whether a number is divisible by 15 or not? The number should be divisible by both 3 and 5. Now how can you tell whether a number is divisible by 16 or not? You have to tell that you have to see the last 4 digits of a number. The last 4 digits of a number is divisible by 16, then the entire number is divisible by 16. Now how can you tell whether a number is divisible by 17 or not? The last number should be the last digit when you multiply with 5, and the resultant number minus remaining numbers. If you take the difference, if it is 0 or if it is a multiple of 17, both times it will come in 17 table or it is divisible by 17. How can you tell whether a number is divisible by 18 or not? It should be both divisible by 2 and 7. And how can you tell whether a number is divisible by 19 or not? Both times it should be divisible by, the last number should be multiple of 2 and remaining numbers plus resultant number. Don't fall here. Please be careful while you are doing 19 table or 19 multiples are divisible by 19. You have to always take here as plus. Clear? So that is about divisibility rules.